In our last video, we had just completed this problem and we were reviewing back through the steps that we had taken on our calculator. So we went to statistics and went to edit, and we cleared our lists by scrolling up and sitting on L1 and hitting clear enter. The same thing with L2. And then we put our blood alcohol content in list 1, and we put our risk values in list 2. Then to graph that, to see what kind of a graph it was, we wanted to use our stat plot. So that's second y equals to get to our stat plot. We picked the first one and turned it on, chose a scatter plot and told it to use list 1 for our x and list 2 for our y, any value you want to mark in any color. Then to get it to set the window for us, we went to zoom, and then we went to number 9 zoom stat, and then that gave us our graph so that we could clearly see that it was exponential, and we would do an exponential regression. So to do that, we went back to statistics, same place we put our lists in edit. We go over to calculate, and then we're going to scroll down past the linear regression that we did before. We'll scroll on down until we get to our exponential regression. So we'll tell it that we want list 1 in X and list 2 in Y. Nothing in our frequency. Again, to get the calculator to type our regression equation in Y1 for us, we do alpha trace to get that Y1 right there. And so then we hit calculate, and it created the equation for us. Now, the value that they come up with for B was a little strange. So let's look at that for just a second. This is what our calculator gave us with this E in it. Now, that's not the natural exponential, that's a lowercase e. This is the calculator's way of writing scientific notation. That's their version of times 10. So that would be like times 10 to the, and then whatever this number is the exponent. So that means we're going to take this decimal and move it 10 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll have to add a 0 there for the 10th spot. So that's our B value. So this is our A value times, this is our B value to the X. Also notice that our R value is 0.986. That's very close to 1. So that means we're going to have a very good fit, and that is going to be a strong correlation. Because it's a positive number, it's a strong positive. And sure enough, if we hit graph, then we can see the graph the calculator created in that regression is a good fit for the points that they gave us. Then the second thing they asked us was to use the model to estimate the risk associated with a blood alcohol content of 0.16 by putting 0.16 in for X in the model equation that we have and solve for Y. Now, here's that equation that we just had on the previous page. All they want us to do is just put 0.16 in the place of X. So we definitely can do that by hand. I mean, you can type this whole thing in on the main screen of your calculator and just put a 0.16 right there. And that's going to give you 26.35 if you do. However, there is an optional little shortcut that you can have your calculator do that for you. So what you would do is go to second trace, which is our calculate menu. That's the same place we've done maximums and minimums and intersections. And so I would choose value, and I can give it any X value that I want. I just start typing it. So I typed 0.16 and hit enter, and then it tells me, it plugs that X value in for me and tells me what the Y value would be. So our conclusion then is if a 160-pound person drives after having 6 drinks, they're about 26.35 times more likely to crash than if they were driving while sober. Another thing is this an interpolation or an extrapolation? Well, 0.16 is a number within the table that we had. Our table went from 0 to 0.21, so 0.16 is within those values, so that's inside interpolation. But if they had given me something like 0.23 or something that was outside our largest value of 0.21, that would be extrapolation. So interpolation is when they ask you for an answer for a data point that is inside the data set. Extrapolation is when they ask for a value outside of the data set. All right, so the nice thing is once you know how to do a regression, they all work the same way. So the next thing they ask us to do is logarithmic regression, but you'll notice we're going to do the exact same thing. And so for our logarithmic, if our b value is greater than 0, then the model is increasing, and if it's less than 0, then the model is decreasing. All right, so you'll notice our steps are going to start the exact same way. We're going to go to statistics and go to edit, clear out any values by going up and sitting on L1 and hitting clear and then enter. And so that gives us clean lists, and then we can type in the data that they provide for us. Then it says graph and observe a scatter plot of the data using the stat plot feature. So to get to stat plot, again, that's second y equals. We'll turn that plot on. We'll choose a scatter plot using list 1 and list 2 and any shape you want in any color you want. And remember, you can get your calculator to set the window for you by doing zoom stat. So once we do that, then this is the graph that we get, and we can see that is not exponential, that is logarithmic. So we'll want to do a logarithmic regression. So again, we're going to do the same thing. Go to statistics, the same place we put our information in our list. Go over to calculate, and we're going to go down to natural log regression, LN regression. It's right above the exponential regression. So we'll tell it to use list 1 for X, list 2 for Y. And then again, I want to ask it that once it creates the equation that it put it in y equals for me, specifically in y1. So to get that y1, we do alpha trace, and then we can select that y1 and then hit calculate. So when we do, this is what my calculator generates. So A is going to be negative 7.229806508. That's going to go right here. Plus B is 13.828406661. Times ln x. Now, I just rounded to 2 decimal places down here, but we can keep all the decimal places. It's just whatever we are instructed to do. So now we have an equation to fit that information. And you'll also notice that we have a positive number here for R, so that is a positive correlation. And that's 0.92, so that's still a strong positive because it's close to 1. It's not as strong as our last one was, and you'll notice that our fit is not as good as our last one was, but those points definitely fit that information. All right, so here are the actual questions that were asked from the homework for this type of problem. All right, so first it says use a graphing calculator to create a scatter diagram. That's the same thing as a scatter plot. So that's the same thing that we were doing before when we put the information in list 1 and list 2 and went to second y equals to stat plot and turned it on and choose zoom 9 to have the calculator set the window for us. All right, then it says use the logarithm options. There, just remind you, this is not exponential. Use the logarithm option of the regression feature to find a logarithmic function of this form that best fits the data in the table. So that was where we went to statistics and went over to calculate and chose the logarithmic regression. And these were those steps we just went through a second ago and how it generated that equation. So that would be our equation. All right, then it says use that logarithmic function to find the value of the function when x is equal to 10. Okay, so here's that equation that we just got. You can see it right down here, negative 7.229806508 plus 13.828406661, and then ln x. So that's what you see right here. And for us, they want us to put 10 in for x, so we'll have ln 10. Now, you could absolutely go to the main screen of your calculator and type that straight in, and your calculator would give you this value. Or remember, you can take the shortcut of having your calculator do it for you. So again, the way we do that is second trace, and then we choose value, and then we tell it whatever x value we want, which in this case was 10, and it would give us that 24.6. Now, is this interpolation or extrapolation? Well, again, remember that it depends on whether the data is inside or outside. So if you look at your graph over here, you can see the last point that we had was at x is equal to 4. That was all the data that we had, and they're asking us for x is equal to 10. So this is outside that data set, so that is extrapolation. All right, then it says to graph the logarithmic equation on the scatter plot. So because we had our calculator store it in Y1 for us, we can just hit graph and we'll get our scatter plot and we'll get the graph of that equation together so we can see the fit. All right, and then the last thing that we have not seen yet is it says use the intersect feature to find the value of x for which f of x is equal to 8. So up here they were saying x is 10, find y. Here they're saying y is 8, find x. All right, so to do that, what I want to do is go to y equals in my calculator. So there's the equation that we already have loaded in there that we've been using. And then I'm going to go to Y2 and I'm going to put in 8 so that I can graph them and I can see that point of intersection. If I want to know where they equal each other, where they hit each other, where they intersect each other. And I can get my calculator to tell me that point of intersection. So let me grab my calculator real quick so that I can show you how to do that. All right, so again, as we were saying, there's the equation that our calculator created, and then we've just gone in and put in y equals 8 and graphed it. And so I want to find this point of intersection right here. So to do that, I'm going to do second trace, same place that value and that maximum minimum are. I'm going to choose intersect right there. All right, now, because I could have multiple points of intersection with 10 different equations in y equals, it's going to ask me which two curves do you want to use and which point of intersection do you want me to find. And the way it does that is it says, what's my first curve? So I'll hit, you can see it's already on y1 on the blue one. So I'll hit enter to tell it yes. And then it's saying, do you want me to use this for the second curve? And you can see it's jumped to the red one. It's what's in y2. So I'll hit enter for yes. And then I'm going to give a guess. Now, if there's more than one point of intersection, whichever one I guess closer to is the answer it's going to give me. So I'll hit enter, and then it will tell me the precise point of intersection that when y is 8, x is 3.0082007. So just to review what we did there, we had our regression equation in y1. We set y2 equal to 8, and then we graphed it, and we're looking for this point of intersection. So we went to second trace, which is our calculate menu, and chose intersect. And in essence, you're just going to hit enter 3 times because it's automatically going to put itself on y1 and then on y2, and then you can guess close to your point of intersection. So in essence, all you have to do is hit enter 3 times to confirm those 3 things, and then it will tell you that point of intersection. And so that's what we got right here, that 3.0082007.